this tutorial, I want to talk about path and mediation analysis. I want to say that path analysis is just a subset of structural equation modeling, and it can be analyzed using multiple linear regression. And the work of path analysis is to specify a system of equations that are involved in a model, a particular model of our interest. And this model can be conceptual or a theoretical. So what I'm saying here is that we have a model, and in this model we have a system of equations that are used in this model. That path analysis helps to specify by quantifying relationship between variables or among variables that are in that model through a path diagram. So the importance of path analysis in crop improvement is that it guides a breeder on indirect selection. Direct selection, once you get that there's a significant relationship, the causal relationship are significant, then a breeder can make an informed decision in his or her indirect selection. It also helps in hypothesis testing a model really if it fits the data. This is a path diagram, and this path diagram is the one which has been constructed through path analysis so that to help you understand a causal relationship among variables. Here we have variables here, 3 variables, and this one. These variables are transmitting their effect to this yield. And this is the regression coefficient or the effect of this to this. Also, this one is the effect of this towards this, and this is the effect of this towards this. This here is inequality dependent variable because it depends on this. It's explained by these variables here. These 3 variables are called independent variables because they are not explained by any other variable. These independent variables, they are also called exogenous variables, while this dependent variable is called endogenous variable. Endogenous variable, you can see here, it has this value here which is indicated by these double-sided arrows. This indicates that this is a residue, while this is independent variables or exogenous variable. They have also the same double-sided arrows here, and these are variances. These variances. Another thing I want to explain about this is that we have also double-sided arrows here. This one, you see this one and this one here. This means these are covariates, and this one also covariates with this one, and this covariates with this one. So these are covariates which points one variable and another. But if this double-sided arrow points one individual variable, this stands for a variance. We also have what we call mediation analysis, which is part of structural equation modeling, also explained by through path analysis. Mediation analysis, it helps us to assess the effect of one variable to another, but through another variable. We have 3 variables. We have a middle variable, which is relaying the effect of a particular variable to another variable. That's mediation analysis. So it helps us to test if this mediator really transmits effect of a predictor, variable to outcome. In short, we have 3 variables here in mediation analysis. We have a mediator, which is at the center, and we have the outcome, which is being predicted, and the predictor. So predictor relays its effects to the mediator, and also the mediator then transmits that effect to the outcome. So mediation analysis helps us to see if really we have that kind of arrangement in our model. So we have 2 types of mediation. We have complete mediation and partial mediation. In this diagram, it shows a complete mediation. A complete mediation is that, for example, we have this yield here. this PNC and this HT. This is the outcome, and this is the predictor, and this is the mediator variable. So the predictor variable transmits its effects to mediator variable. The mediator variable then transmits its effect to the outcome. This outcome and mediator, these are endogenous variables because they are being explained. So for example, yield is being explained by HT and HT is being explained by this. But this PNC, this is our independent variable or exogenous variable. So the effect of PNC, which is transmitted indirectly to yield, that's the indirect effect of PNC to yield, which passes through C and B, is just a multiplication of effect C times B. We have partial mediation, whereby the effect of PNC partially passes through mediation and also partly passes directly to yield. So when PNC, the portion of PNC that goes direct to yield, this path I've called A star. And this which directly passes to HT is C. And this one HT, this path HT directly to yield is P. So you can see PNC in this path, it does not go directly to yield, it passes through this mediation. So to get the effect of PNC to yield in this partial mediation is this indirect effect, which is C times B, which is a direct effect, plus this direct effect. This diagram just is to illustrate to you that we can have so many exogenous variables or independent variables that all of them, they have some portion which directly goes to the outcome variable and a portion which passes through the mediator variable. But it's not always like that, but also it can be like that. So next, let us switch to R so that we can see how to do path analysis and mediation analysis in R. The first thing we do is, let me set my working directory. Then I import my data. Then I can use head function to view my first 6 lines of the data. They are here. This is the yield variable, and this HT, PNC, TLR, and HM. All these variables, we are going to use them to construct a path diagram or to do path analysis. And also we can use them to do mediation analysis. One thing I want you to keep in mind is that I'm using YLD, which is yield, as the outcome variable or as the dependent variable or as the endogenous variable. So we are going to use a package called lavaan. You install this package lavaan, then we import this lavaan to the library. The first thing to do in this analysis is to specify the model. Now you specify that this is the model which we are going to use. We have this yield, which is a dependent variable. This yield is just predicted or explained by all these 4 variables here. It's being explained, we use tilde. This sign here is called tilde. It says that yield is explained by these 4 variables. So yield is the endogenous variable. These 4 are exogenous variable or independent variables. This HT, whatever you are seeing here, which is 2 tilde, means that these are covariates. That means HT, which HT covariates with HMN, and also covariates with this, and also HT covariates with this. This here means this HM covariates with TLR and PNC. This is what you're seeing here. This one here is TLR covariates with PNC. This is how we write the covariates. You remember I explained about the covariates, and this is how we put them. So this shows the relationship between the dependent and independent variables in this model. So we specify this model, then we run. After running, Then we have to fit the model now. We have just specified that this is a model. Now we have to fit. Fitting this model, we are going to use structural equation model, and this is a function of lavaan. So we give it this name, model 1. Then we specify that what's our model? Our model is the id.model that we specified here. Then we are going to use our data. That's why I've said data is equals to data, the way I named it. Then we run. Then the last thing which we do is to summarize, get the summary of your model. You write summary, function summary, then model 1 which we did fit here, and we need to see the fit measures, the measures that are going to show us that this model really fits the data or not. So fit measures is equals true, and R square, we need to see the regression analysis of this model. We say true. Then we run this. After running this model, down here on the console, in the console, the model, the fit measures and regression analysis, they are here. I want to say that the first thing which you need to look when this kind of analysis has been displayed is the degrees of freedom. The degrees of freedom here is 0. This means that our model is just identified. A just identified model means that this model fits our data well, then we don't need to explain it. But if your model has a degree of freedom of more than 0, that means the model is of identified. And an of identified model, you need to look at this fit statistics to see if your model fits. Also, if the DF is less than 0, it means that your model is under identified. So you need to also to explain using the fit indices. I've given 5 fit indices which you can use to explain your model in case your degree of freedom is more than 0 or less than 0. For that case, let me explain what the indices that you use. We use a chi-square test, which if the p-value is 0.05, then you say that is significant. You can see here is 0.00. This means it is less than 0.05. Then the next thing is CFI, this comparative fit model, the comparative fit index is here, CFI, which is comparative fit index. It has to be more than 0.09, which is the case here. And the other one is this TLI, TLI. It has to be more than 0.95, which is the case here. And also we have to see these errors. You can use this error here. Which is root mean square error of approximation, which is here, it has to be less than 0.08, which it is the case here. Also, there's the last one here, which you have to see, standardized root mean square ratio, SRMR. It has to be also more than, and it has also to be, it has also to be less than 0.08, which is the case here. This, you only explain this if your model, the DF, is more than 0 or less than 0. The next thing which you have to note that down here, these are regressions, and these are the effects of these variables, and these are p-values. For instance, we have the effect of HT, HMN, TLR, PNS, all of these directly transmitting their effect to yield. For instance, HT, the effect of HT towards yield is this one. HMN to yield is this one. TLR to yield is this one. PNC to yield is this one. And you can see their significances here. They are not significant. And here we have the covariances. These are the covariances. HT covering with this, HT covering with this, HT covering with this. These are their covariance and their significance. HMN covering with this. These are the covariances. Then also we have the variances of these independent variables. These are variances of independent variables, and these are covariances of independent variable, and these are the effects of independent variables to dependent variable. That is it. And now the next thing which you need to know is how to draw a path diagram. Remember, we developed our model here, model 1. we need to draw our path diagram in R. We use this package called SEM plot, which is structural equation modeling plot. SEM plot. You install that, then you load it into the library, then you use this function SMPath. You write object. The object, this is what are we using to draw the path, is model one, which we developed here. We call it model. We call it model one. That's the one which we are going to use to draw. That's why object is model one. What are we doing with model one? Model one, we are going to draw a path. And what labels we're going to use? We are going to put the parameters. So if you do that and run, it will draw. It has drawn it here. Let me zoom it so that you can see. You can see this model. This is a dependent variable, and this is a residue here. And these are effects. These are effects coming to the yield from the exogenous variables or from the independent variables. And you can see here we have variances of these, and also we have the covariances, because these exogenous variables or independent variables, they are allowed to covary. So this is how we draw this path diagram. You can also tweak it so that it can fit your preferences. We reached here, so you can add style, layout tree, rotation, so that it can rotate the way you want. The size, the size of these boxes here, and the color which you like. I like blue. The h.label or cx. This is the size of this fonts here, and the label or cx, the size of this font inside here. So if you run that after tweaking, it gives you this. It looks nice. It looks nice. You can tweak it and use. So this is the script which you use to tweak. That's all about path analysis. Now, the next thing which we are going to look is the mediation analysis. In mediation analysis, we are going to see if we have a mediator variable that transmits the effect of predictor to the outcome. For instance, we can see if HT can be a mediator which transmits the effects of these three variables to yield. Therefore, these three variables are going to transmit their effects to HT, and HT then is going to transmit these effects to yield. So that's what I want us to specify in this model. HT is receiving the effect of HMN, TLR, and PNC. HT, this PNC, TLR, HMN, they are transmitting their effect to HT. Therefore, HT is a mediator variable. Then later, HT will transmit to yield. HT transmit to yield. This is what we have written here. These other two here, lines here, is just specifying covariates, that HMN, this variable here, covaries with this and this. Also, this TLR, this one, covaries with this. But of importance here, which you need to see, is that these three variables transmit the effects to HT. Then later HT transmits to yield. Therefore, HT is the mediator variable. So what we do, we run that. After running that, we fit the model. We use structural equation modeling of lavaan, SEM. Then the model which we are using is this one, ID model that we have developed here. Then we specify the data that we are going to use. Then we run. The next thing we do is just to draw this path diagram the way we did the other time. You can see now here what we have here is this diagram here. These three variables here are transmitting the effect to HT, and then HT transmits the effect to yield. Therefore, this is mediation analysis. I want to tell you that in mediation analysis, this one is a dependent variable. Also, this one is a dependent variable because they are being explained. Okay, so this from here to here is a direct effect of HT to this one, but the effect of PNC to yield is not direct. The same to this and this. It's indirect through this mediation variable. Also, this is the residue. This is the residue. This is the variance of those variables. And I want to say that we have complete mediation and partial mediation. In complete mediation, one variable, for instance, this PNC, transmits its effect to HT, and HT later transmits that effect to yield. That's complete mediation. To draw this, you just specify this model. PNC transfers its effect to HT, and HT transfers the effect to yield. Then after specifying this model, we fit as we did here, because we have called ID model. A model is ID model. Then we draw this. Here it is. You see this one here? PNC, which we specified here, up here, PNC, transfer its effect to HT. As you can see, it has transferred to HT, and HT transfers its effect to yield. So this is complete mediation. So mediation is complete here. We have also another one called partial mediation. Partial mediation is where we have indirect effect and direct effect. For example, PNC, part of this is transmitted through mediation, and so part of this is transmitted directly. This is what we have specified here. PNC transfers its effect to HT, then later HT to yield. But also PNC transfers its effect direct to yield. So we have direct and indirect effects here. We do that, we fit the model, and then use here we draw that. You can see it here. PNC has just done what? Has transferred its effects, some of its effects to HT, which HT will just transfer it to yield, and so directly here. Now to find the effect of PNC to yield is just addition of this indirect effects, that's this one times this one, plus this one. You remember we talked about that. Is the effect of PNC to yield is 2.47 times negative 0.8 into brackets plus 3.45. So let's test for presence of a mediation variable. Is this mediation variable? We are testing this to see if it's there. So what we do, we give this, you remember we gave these parts names, and I can repeat to show you that PNC transmitting its effect to yield, PNC directly to yield, I call it A. This is part A here. You remember that diagram? This part A here. Then HT transmitting its effect to yield is P. HT transmitting to yield here is B. So this is part A and this is part P. The last part is PNC transmitting its effect to HT. This is part C. PNC transmitting. You see its arrows, the arrows where they're moving, pointing to. So this is part C. So this is part A, this is part P, and this is part C. Another thing which I want to specify is PNC indirectly transmitting its effect to yield, which is C, this part C times B, C times B. So we have these four direct parts, these three. We have these three direct parts, this one towards this one towards this one, and this one towards this one is what's here. Then this one indirect, this one transmitting this through this. So we run that, we fit that model, and we view that summary. Okay, so if we come down here to view that summary, we just go direct to regression, because we come up here, everything is like the previous one that we had. So let's come to regression. You can see here PNC transmitting its effect to yield directly, PNC to yield, PNC direct to yields, its estimate is 3.45. It's here, and it's significant. But HT transmitting effect to yield is negative here, which is negative 0.079, which is this one, but it's insignificant. Therefore, this transmitting here is insignificant. And again, PNC transmitting its effect to here, HT, its effect here 2.47 here, and it's significant. So this one transmitting directly to here is significant. This one here directly is significant, but HT direct to yield is not significant. Those are direct. Let's look at indirect here. CB, the indirect variable, indirect effects. This A times this C times B. You can see its effect is here, but it's not significant, not fair. So PNC does not indirectly transfer its effects through HT, but does that directly to yield. However, you see this test is called, this kind of test is called a Sobel test. And the Sobel test has a problem that it takes that the effects, this indirect effect, the distribution of indirect effect is normally distributed, which is not the case. Therefore, to be sure, we use this resampling method. A resampling method. In the resampling method, we are going to use a method called percentile bootstrapping, because it's going to use random numbers. Because it's going to use random numbers, we use this set.sit. We put a number here so that we can regenerate again those random numbers. We run. Then we fit our model. Here we use the SEM of lavaan. The model that we used, this is called model ID model 1. You remember we did a model here called model 1 here, which we specified. We specified model 1. Instead of now coming here, we come to this one here, resampling. We use ID model 1. Data we specify. Then we use standard error. We are going to use bootstrap standard error. And how many bootstraps are we going to use? You can use 5,000, 6,000, depending on the 5,000, 6,000, it's okay. But now because of the speed and demonstration, I'm going to use 3,000. So we are going to have 300. We are going to have 300 iterations here. So we run that. It's going to take some minutes. So after running that, then we use this function here called parameter estimates. See, parameter estimates. What are we going to estimate is fit model 1 here, which we fitted. Is the one we are going to run this parameter. And confidence interval, yes, we have put it through, and the level of that confidence interval is 0.95. And the bootstrap confidence interval type is percentage, because we are going to use percentile bootstrapping. So we are going to use percentile here. We run. So as you can see, we have this indirect effect. We want to be sure that this p value here falls within the CI lower and CI upper, which is not the case. Since this p value has fallen outside the upper and the lower CI values, then we say that this indirect effect is significant. This indirect effect is significant. Therefore, there is mediation. My name is Wilfred Abincha. Kindly subscribe, like. I hope this was helpful.